Okay, now we're taking a step further. For each problem, find dy and delta y given x-naught and dx, which is the same essential thing as delta x. Okay, so notice, whoops, this is what we're given. So when you do what we did before, when we're finding our dy and delta y, we're going to then use these values that we have to plug it in. All right, so this is negative 2x minus 4, and then the dx goes over here. Now the delta y is going to be a pain, so it's a negative on the outside. X squared is x plus delta x squared minus 4 times x plus delta x, subtract 3, subtract the original function, negative x squared, subtract 4x, subtract 3. All right. So when we square this, it becomes x squared plus 2x delta x plus parentheses delta x squared, subtract 4x, subtract 4 delta x, subtract 3. Now there's a subtract on the outside, so each one of those, subtract a negative, that's going to be add a positive. Add x squared, add 4x, add 3. And then we're going to find their pairings. Positive 3, negative 3. Positive 4x, negative 4x. X squared, negative x squared. So all of those are going to cancel. So what you have left is delta y is equal to negative 2x delta x, subtract delta x squared, subtract 4 delta x. Okay, now we take the values for x and delta x and plug it in to get the numerical value for y. So negative 2 times our x-naught is negative 1. Our delta x is 3/2. Subtract 3/2 squared minus 4 times 3/2. And then you could just type all that in the calculator. Negative times negative is positive, and so that's going to be 2 times 3/2. The 2's are going to cancel, so we're going to have a 3. Subtract 3/2 squared is 9/4. So we could actually rewrite this as 12/3. We could write it as 12/4. And then if you cancel that, that becomes a 2. That subtracts 6. But instead of 6, we can write that as 24/4. All right. So 12 subtract 9 is 3. 3 subtract 24. Looks like this is negative 21/4 is the delta y. If I didn't make a clerical error up there someplace, which is plausible. Now, on the cubed ones, this is going to be a pain. You'll need the Pascal's triangle. So our dy is 3x squared dx. But when we find the delta y, it's x plus delta x cubed plus 3 minus x cubed plus 3. Well, this thing cubed Pascal's triangle is 1 parentheses plus 3 parentheses plus 3 parentheses plus 1 parentheses, then this plus 3. Now we're subtracting x cubed, we're subtracting 3. Well, if you remember Pascal's triangle, hopefully you remember this from pre-calc. What goes in the parentheses is the first term goes in descending order. So this is x cubed, this is x squared, this is x to the first. X to the 0 is 1, so we don't have to write x to the 0. All right, and then the other one, it goes in ascending order. So it's, and by the way, this cubed, if you type in 11 cubed, you're going to see this number. That's where we get the 1331. And if you remember Pascal's triangle, this is binomial expansion. So this is a binomial cubed, binomial squared, binomial to the first, a binomial to the 0 power, which is 1. All right, so this is delta x to the first, delta x squared, delta x cubed. That is really hard to read. Okay, that's a little bit better. All right, so this x cubed is going to cancel with that other x cubed. I'll leave it there for just a second. Then this will be 3x squared delta x plus 3x delta x squared plus delta x cubed plus 3 minus x cubed minus 3. So negative x cubed, positive x cubed. Negative 3, positive 3. Those are the things that cancel. All right. Oops. These are supposed to be a delta y's. If that was confusing, I apologize. So 3, now instead of the x, we can put negative 1 squared times delta x, negative 1 half, plus 3, x is negative 1, negative 1 half squared, plus negative 1 half cubed. All right. So negative 1 squared is 1, so that's 3. 3 times negative 1 half is negative 3 halves. This negative 1 half squared will be positive, but negative 1 times 3 is negative. So this will be negative 3 over 4 because the 2 in the denominator also get squared. And then cubed, a negative cubed will still be negative. And 2 cubed is 8. So let's see, if I multiply this top and bottom by 4, that becomes negative 12 eighths. I multiply here, top and bottom by 2, top and bottom by 4, top and bottom by 2. So negative 12 over 8, subtract 6 over 8 is negative 18 over 8. Subtract 1 is negative 19 over 8. Again, assuming I didn't make a clerical error up there someplace, which we math teachers do sometimes. Okay, so there's that example. So delta y, since there's not a negative sign there, this will just be 1 over 2 times the square root of x. Oh, what we needed to do also, sorry, on the other two, we needed to come up here and plug in the x and the delta x. So I'll go back and do that in a minute. I'll finish this one. So dy, or delta y, is 1 over 2 times x plus delta x minus, we don't use that, we use the original. I apologize. X plus delta x minus square root of x. So this is pretty straightforward. The x is 3, the delta x is 7/2, so this 3 will be changed to 6/2 minus 3, which I'm going to change that to 6/2, see what happens. So 6 plus 7 is 13. So 13/2 minus 6/2, which is, so we don't want to leave the radical 2, so we're going to multiply top and bottom by radical 2. Now, 6 times 2 is 12. 12 is the same thing as 4 times 3, so a 2 is going to come out. And then that's going to cancel. So up here, I should have just left that as 3. That would have simplified things. Now, if we want the 3 to have the same denominator, we could write this as minus 6 all over 2. Because since that was going to be a subtract 3 is the same as this, and then they can share the same denominator. And sometimes professors are going to prefer that. Okay, so then we also come back up here and we put in x and dx. So this becomes 1 over 2 times the square root of 3 times 7/2, which is 7 over 4 root 3, multiply top and bottom by root 3. So dy, 3 times 3, that's 3, that's going to be 12 down here, is 7 root 3 over 12. And then if we come back up here, we plug in the -1, and we plug in 3/2. So this becomes -2 times -1, subtract 4, times 3/2. So that becomes 2 subtract 4, which is -2, times 3/2. So dy is equal to -3. All right, and up here, there was another one. Nope, this was just general. Okay, I think that gives you an idea on how, see if there's another weird one. Nope. And then the next one will be linear approximation. All right.